Good morning, good morning. Welcome. I hope you guys were able to make it to some of your sessions of the electives fair. If you've been having frustration with that, having a hard time getting on the document, go ahead and go to your Teacher Schoology page for advisory and look at the schedule for today and write down the codes, the Google Meet join codes for the sessions that you want to attend the rest of the week. That way, you don't have to have access to any documents. You can just open the Google Meet tab and type in the code for the session you want to attend tomorrow. You get to attend 2 sessions a day. So that's my recommendation if you're having trouble with that. If we take a look at our agenda for today, just a reminder, the retake for 6.2, which is in the folder just below today's folder, is due by this Friday at 4 p.m. Remember, Friday is the end of the quarter, so any makeup work that you need to do, anything like that, is due by Friday because teachers are submitting grades over the extended break for you guys. Remember, after Friday, you guys don't come back to school till next Thursday, so you have almost a week off school, so that'll be fun for you. Teachers do get a holiday in there too for Inauguration Day and Martin Luther King Day, and we'll be entering your grades that Tuesday and over the weekend. So any questions about that before we get started? Okay, so we do have a Pear Deck to practice today. You watched your video notes for today, and we're going to be working on mid-segments and parallels. And I cannot emphasize enough how important it is that you're watching the video notes before you come to class, okay? We'd like you to practice taking notes. That's a skill you're going to need moving forward. It's a super important skill, and that's why we provide the blank notes and completed notes for you to check yourself against in the folders every day. But it's just really important that you watch the teachers teaching these topics before they come in. We kind of go over the basics and we work problems and examples, and we want to answer questions in class, but that foundational teaching going on in that video is super helpful. And so it's there and you can go back and refer to it again. Remember, it's always in the day just before. So if you need help with mid-segments and parallels after today's lesson, you can just go back to the lesson right here that has those video notes on mid-segments and parallels. And there in the folder, you'll get the link and can watch it again and can check your notes again. So the blank and completed notes, video notes, always there for you. Okay, so remember your ALEKS that you may do 20 minutes of ALEKS twice a week. That has to be done by Friday because I'm going to be pulling your ALEKS minutes for your extra credit. And if you have 240 minutes and 24 topics completed, you can get 3 points added to your quarter average, which is a huge deal. So make sure and do your ALEKS so you can get caught up during your study hall time. That's a great use of your study hall time. Okay, so let's do our Pear Deck. After we're done with our Pear Deck, your assignment today, no video notes to watch for next time because next time we're doing an assessment. So Friday's assessment will not go on this quarter. Okay, Friday's assessment will not go on this quarter. So your grades for this quarter are pretty much set unless you're working on that retake. And then unless you have extra credit coming in from ALEKS. And I've got a few, like the 5.1, 5.3 retake, I've got a few things that I'm grading in the process of filling in for little holes for people that have been out. No problem, Maya, I haven't taken attendance yet, you're good. But so your grades are pretty close to where they're gonna be final grades. Well, so we do have that quizzes that we're gonna work on. The link is here, it's already assigned to you in your class in quizzes, but let's go ahead and get started today with our Pear Deck. Now, I don't have the code here is up here in the corner. It's XTVISW. I want to see everyone in the Pear Deck. I know that a lot of times you like to follow along with me, and that's fine. But remember, I always want to see your beginning equation and your final answer in the Pear Deck so I can get an idea how you're doing if you're doing okay. I prefer that you work the entire thing in the Pear Deck, and every day when I close the Pear Deck, I send out a thing that shares your results to you. So if you check your email daily, you're getting a copy of your slides and the blank slides to your email from the Pear Deck if you log on and participate in that. Okay, so let's go ahead and get you guys on there, XTVISW. And I want you to read over this little slide, refreshing on what a triangle midsegment is while I get attendance in real quickly. Avrin's out today. Carmen's not here today. Justin's not here today. Tristan's not here today. Okay, let's do this. So it says a midsegment is a segment that connects the midpoint of two sides of a triangle. Triangle midsegment theorem tells us if a segment joins the midpoints of two sides of a triangle, meaning if it's a midsegment, then the segment is parallel to the third side, so it's going to be parallel to the remaining side, and it's going to be half as long. Okay, now that's, for me, much easier to understand graphically. So let's look at some pictures. Okay, so here we have a triangle. And this line segment AB is the base of that triangle. If we take or I can think of it as the base. You can think of any of the sides as the base, okay? So we have this segment, line segment CD, that connects the midpoint of these two sides. Now, how do I know it's the midpoint of these two sides? How do I know point C is the midpoint? Because you can see from the congruency marks that it splits it into two equal parts. Similarly, I know D is a midpoint of line segment EB because from the congruency marks, I can see that point D splits line segment EB into two equal parts. That's definition of midpoint, right? That it splits it into two equal parts. So line segment CD is a midsegment because it connects the midpoint of two sides of the triangle. So our triangle midsegment theorem tells us that means then that it is parallel to the third side. Okay, it's parallel to side AB, the remaining side, and it's half the length. So my question for you is, if line segment AB is 26 units long, how long is line segment CD? Okay, go ahead and fill that in. Let's take a look and see how you do. Right, that shouldn't be a hard question. Let's take a look. Let's see. Okay, and Adib showed us exactly right. Line segment CD there. Let me advance mine off of his. Okay, line segment CD, that mid segment, is just going to be line segment AB divided by 2. Half of it means it's just divided by 2, and so 13 is the correct answer. So good job there, Adib. Okay, let's try another problem. Solve for X. Now, we've got to use our geometry skills. We've got to look with our geometry eyes when we look at a picture. So tell me, what do you see going on here? What do you notice? What are you thinking? What do you see? What are you thinking? Well, I can tell you what I see. I see that this is a midpoint because this side is broken into two equal parts. I can see this is also a midpoint because this side is broken into two equal parts. Very nice. And I even see some of you labeling it in your picture. You're using that vocabulary that we know that line segment, okay, this line segment that connects those two midpoints is a mid-segment. And I see some of you even labeled it. I love that use of the vocabulary. That's a mid-segment. Okay, now when we want to solve for x, we can set up any equation that we know is true that involves x. So when I look at that, I have the mid-segment right here. And I also have the third side of the triangle that it's parallel to. We know that it's parallel to the remaining side of the triangle. So I know those two lines are parallel. And I also know that the measure of the mid-segment is half the measure of the remaining side. So how can I put that in an equation? You've got two different choices of how you can write that. And I want to show both of it because some of you will like one and some of you will like the other. There's two different ways to write that. Kind of have a lot of color going on here. Let me see if I can uncover that a little bit for you. Okay. Now, for this problem, the fact that those two sides are parallel is not something we're going to use. But we're going to use the fact that the mid-segment is half of the remaining side to solve for x. So there's two ways to write this. We can say that the mid-segment, 6x plus 7, equals, that means is, half of the remaining side, which is 19x minus 28. Did you notice how I said in English what I was writing in mathematics? Being able to translate from words to an equation is super important, okay? So this says 6x plus 7, which I'm thinking of as my mid-segment, is half the remaining side of the triangle, okay? So that's one way to write it. It's not my favorite way to write it because it involves fractions, and none of us like working with fractions. So let me show you another option that's also valid. If this mid-segment is half of the remaining side, that means that remaining side, 19x minus 28, is equal to 2 of the mid-segments, 2 of the 6x plus 7. Does that make sense? If the mid-segment is only half of the remaining side, it would take two of them, 2 times the mid-segment, to equal the remaining side. Questions for me about that? For me, the one on the right in purple is the one that I usually like to do because it avoids the use of fractions, but the one on the left might make more sense to you because we said the mid-segment is, okay, so let me write the words there. The mid-segment is half the remaining side. Okay, so that's very easy to translate and remember what we know is true. Well, either way you start, we're going to end up with the purple step as our second step. So if we start with the one on the left, the first thing we have to do is get rid of the fractions, right? So how do we get rid of a fraction? We multiply both sides by the denominator. So there's a 2 in the denominator there, so I'm going to do 2 times this side, and I'm going to do 2 times this side. And when I do that, 2 on top cancels with the 1/2 on bottom, and that just leaves me 19x minus 28. And a better way to show this so that it doesn't confuse you. Okay, it's just to put that in parentheses there. Okay, so we're going to multiply both sides by 2. That 2 on top cancels with the 2 on bottom. And then that leaves us 1 times 19x minus 28, which is 19x minus 28. And that leaves us 2 times 6x plus 7. So you can see, even if we didn't start with it as our first step, our second step is equivalent to this side. We've got the 19x minus 28 equals 2 times the 6x plus 7. Okay, let's use our algebra skills and finish solving that. Let's use our algebra skills and finish solving. I'm going to go ahead and finish solving the one on the left. You can work on the one on the right, whichever is your favorite. If we do correct work, we'll end up with the same correct answer. 2 times 6x is 12x. 2 times 7 is 14. Equals 19x minus 28. We want to subtract 12x from both sides because we're trying to gather our x's to one side. When I do, that goes to 0. 19x minus 12x gives me 7x on this side. So now I want the numbers on the other side. So I'm going to add 28 to both sides. That'll cancel. 14 plus 28, that's going to be 2. Carry over 1, 42. Is that what you got? Okay, last step. I'm going to divide both sides by 7. And that gives me x equals 42 divided by 7 is 6. So 6 is my final answer. Is that what you got for x? Let's take a look. I'll give you a second to finish the algebra. I'll leave mine up there for you to check. Very nice. I'm seeing other people get it. Very nice. Good job. Adib, that's a good start. You've got the 12x plus 14, and now you just need to set it equal to the third side. Grace must be working on her paper and just typing her answer. That's fine. That's good. Okay, what questions can I answer? Let me see. We have a question from Benjamin. Hi, Jessica. Nice to see you this morning.
Oh, sorry, that was an accident.
I was like, we're happy to see you. Okay, Benjamin asked, you can also divide 19x and negative 28 by half, can't you? Yes, and Benjamin, that's what we showed is the other option right here. Multiplying by a half is the same as dividing by 2. Make sure you call it dividing it by 2, not dividing it by half. Okay, dividing it by a fraction would be different. Okay, but that's exactly what we were saying on the first one, that you can take half of the third side. So if you like it better, so what it sounds like Benjamin is saying is that he would like to write it as the 19x minus 28 divided by 2. And you might like that better than writing it as half of 19x minus 28. It means the same thing. Multiplying by a half is the same as dividing by 2. So half of the third side equals the mid segment. And the thing I like about writing it that way, Benjamin, I think that was a good idea. The thing about writing it like that way, it helps remind you that to get rid of that denominator, you just need to multiply both sides by 2. Okay, and when you do that 2 and that 2 cancel, and we get what we had here, which is 19x minus 28 equals 2 times 6x minus 7. And so you're going to distribute, and you're going to get the same correct final answer. That will also work, okay? It's 2 times the 6x minus 7. Okay, so if you actually, so when we get this problem here, Benjamin, and we've got 19x minus 28 divided by 2, okay? That divided by 2 does not equal, oh, you did 9.5x. You could do that too. So he said instead of dividing by both sides by 2, he went ahead and divided 19x minus 28 by 2. So 19. So basically what he did, when you have something written over a common denominator, let me go to it. You can write it separately. You can write each term separately over that denominator. I'm going to distribute this. Gives me 12x minus 14. Okay, so he did the 19x divided by 2 minus the 28x, the 28 divided by 2. 2 doesn't divide evenly into 19. So Benjamin got 9.5x equals plus minus 14. Let me fix that sign there. Minus 14. And it should be 12x minus 14 that it's equal to here, Benjamin, because, oh, well, you didn't do the dividing by 2. Okay, sorry. Let me start. I want us to do this. Let me see if I can find Benjamin's slide and share it rather than doing this, because he didn't divide both sides by 2, so he's not distributing. Okay, so if we look at this, he started up here, but he did not divide by 2. Okay, so let's go back to this original here and look at what he was saying. So he took the 19x minus 28, the third side here, and he divided it by 2 and said half of it should be equal to the mid segment, which was 6x plus 7. And thanks for your patience on this. I should have found Benjamin's slide and just shared it, but this is what Benjamin did. So he just said half of the third side equals the mid-segment. And he divided the 19x individually by 2 and got 9.5x. He divided the 28 individually by 2 and got minus 14. So that equals 6x plus 7, okay? And then he's just going to finish solving that problem. You can totally do it. We've just got decimals now involved in it again. So if we subtract 3x from both sides, or sorry, not 3x, 6x. I was seeing what answer I would get when I subtract 3. Subtract 6x from both sides to gather your x's to both sides. That's going to give me 3.5x. I want to add 14 to both sides. That gives me 21. And then last step, to get the x by itself, we're going to divide both sides by 3.5. So we get x equals 21 divided by 3.5. Does in fact equal 6, because correct work will equal correct answers, okay? So we do get the same correct answer that way. This is just proof again that there's always more than one way to work a problem. Benjamin, I would argue that it would be just as efficient if Ms. Weaver didn't take a million steps to understand and write what you were meaning correctly. And that's where I said if I had seen your work to share your work, that would have been easier for us to all get on the same page. The first few times that I was trying to understand what you were asking, I don't think I correctly conceptualized the problem. Like I said, if I directly worked through that, that would be fine. You just will have decimals in your problem, which is fine. Okay, so I don't want to deter you from doing that, Benjamin, because your logic there, your natural intuition was a correct way to work the problem, okay? And it does still yield the same correct answer. So feel free to try it next time. I can show it next time, working it directly now that I understand what you're wanting to do. Both ways work and both ways are mathematically correct, okay? Questions about that from anyone else? You may not have stayed with me through all that if you weren't, Benjamin, and involved in that. Hopefully you can. It's good to follow it. It's good to see the way different people think and work problems. It's one thing I like about seeing and sharing your work, okay? So I do like that, Benjamin. Totally works. Okay, let's try another problem altogether. What is the perimeter of triangle ADE? Now, can I just say that letters are super important when you're working in these problems that have multiple triangles going on? Let's make sure we notice what triangle they're talking about first. When they say triangle ADE, they're talking about ADE, they're talking about that big triangle. Now, perimeter is something you guys are usually very good at. How do we find perimeter? We just add up the 3 sides. The perimeter here is going to be the measure of AD plus the measure of AE plus the measure of DE. We're just going to add the 3 sides of the triangle. This is called the geometry setup when I write up how I'm going to find it with letters rather than with the numbers. And I like to do that here to make sure that you're pulling the correct parts. So the perimeter is just going to equal the measure of AD, which they gave us there in blue. It's 50, or a bluish purple. It's 50. Plus the measure of AE, they also gave us there in red. It's 48. But we don't know the measure of DE yet. We don't know what it is, so I'm going to call it X. You can use another variable if you'd like, okay? So thoughts or ideas on how we can solve for X. What do you see? What are you thinking? How could we solve for X? What do you notice? What do you spy with your geometry eyes? What do you see as you're looking at that problem? And I'd love for you to unmute and tell us, just because different people are going to see different things or have different insight. Okay, so what do you see? What are you thinking?
If we know that BC is 26 and that's half of what DE is, we can just times that by 2 and get our third side.
Beautiful, beautiful. Exactly right, Grace. Thanks for putting yourself out there and trying. How did you know that BC was only half of DE? How did you know that?
Because it's parallel and it's like the segment that we were talking about?
Exactly. So that's what I mean about what do you spy with your algebra eyes. You have to be looking and notice that point B is in fact a mid-segment, a midpoint of line segment AD. We see this congruency marks. It has the same congruency marks, meaning that's a midpoint. Same thing on the other side. You have to recognize C as a midpoint because you've got the same congruency marks that it splits it into 2 equal parts. So looking at that picture, you have to get your mind thinking, oh, that's a mid-segment. The segment connecting 2 midpoints is a mid-segment. And once you recognize that, once you spy that with your geometry eyes, then we know what Grace said, which is that the mid-segment is always half the remaining side, that third side that it's parallel to. Okay, so since it's half of it, she did it exactly right. Remember, we said there's different ways to think of it. You can think of BC as being half of DE, or you can just realize that it'll take 2 of BC to equal DE. 2 times 26 will equal that third side. So what did it turn out to be, Grace, for the third side? 26 times 2, what'd you get?
I got 52.
And that's exactly right. So X is 52. Now don't stop when you get 52 because that was not the answer they asked for. They asked for the perimeter. So don't forget to come back and add it to your other 2 sides that we already had going over here. 50 plus 48 plus 56. And you guys are good to be using your calculators on this, either your Desmos calculator that we'll get to use on the SOL or your phone calculator. Okay, and so when we add those all up, dun, 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 we should get a perimeter of 150. And I saw some of you had that really fast, by the way, watching your work. Some of you had that 150 on the board quite a while ago, and you were just waiting for Ms. Weaver to finish explaining it, okay? So excellent work. I saw a lot of correct answers, and that's what I said. You guys are very good at perimeter, and this idea of mid-segment being half of that, you're very good at doubling to make the longer side or dividing by 2 to make the shorter side. So good job, guys. Okay, let's try another problem. Are there questions for me? Feel free to interrupt and ask your questions. Okay. And I can always go back. So if I don't give you enough time, just let me know. Okay, if C, P, and T are midpoints of the sides of triangle AEN. Okay, first of all, when you read, you want to start translating to your picture and marking that information in your picture. It says that C, P, and T, so I'm going to go find those points, are midpoints of the sides of triangle AEN, okay? Triangle AEN there is the big triangle, so it says those 3 points are midpoints of the sides of that triangle. So how do we mark that in our picture? How do we mark that it's a midpoint? We mark that it breaks that side into 2 congruent pieces, okay? So that means point C breaks line segment AE in 2 equal parts. That means point P breaks line segment EN in 2 equal parts. And notice each side gets its own congruency marks, okay? Each side gets its own congruency marks. Because we don't know that all 3 sides are congruent, we only know that each of those points is a midpoint of that side. So point T is the midpoint of line segment AN, so it breaks that into 2 equal parts. Okay, so I marked that part that is the midpoint of the triangle. Now let's see what else they told us. PT is 13. So line segment PT is 13. EN is 43. Trying to find EN in my picture. Did it say EN? EN. Oh, EN. Okay, this whole big side here is 43. Okay. And line CP, this little one in here, is 29. Okay, so I dropped the information into the picture. And now let's see if we can use it to start figuring out some different things. Okay, so tell me what you see. Tell me what you're thinking. Carmen, how did you decide on AE? Can you tell us what you were thinking?
I times 13 by 2 because if you like reposition it, AE and PT are like on the same side.
Okay, that's right. So AE and PT, those are the 2 parallel sides if you look at that triangle that way, meaning PT is a mid-segment because it connects the midpoints of side EN and side AN. So it is a mid-segment. So if PT is 13, then she knew that line segment AE, that big side, would be 2 times that. She would double it, 2 times 13, to make the bigger side. And so she was exactly right. That was 26. Very nice. Good job, Carmen. Okay. Let's see. Ashton, how did you decide about AN? I think you have just a teeny little math mistake there, but I can see your thinking's right. So what were you thinking about AN, Ashton? What were you thinking, Ashton? Can you tell us, how did you go about finding line segment AN? This side right here. Oh, your mic isn't working. No problem. Okay. So I like the way Carmen said when she was finding AE, she said if you rotate it that way or think of it that way, okay, because we've got so much going on in this triangle, there's going to be different ways to look at it. And for me, the color coding can really help there, okay? So then when Carmen was finding AE, I highlighted the segments she was looking at both in red, okay? So that PT was the mid-segment of AE. Now Ashton's going to be helping us find AN, okay, which is this big side from A to N. He's going to help us find AN, okay? And so we're just waiting to see what he was thinking. Are you typing, Ashton? I'm waiting to see what you're sharing your thinking. Hopefully you're typing. We don't care if you respond in chat or with your mic, but we just want to hear your thinking. Okay, and so just for the interest of time, I don't want us to take too long on that one. We knew that this side, CP, oh, he was trying to rejoin to see if it would work, okay? So CP we know is 29. Well, notice that line segment CP is also a mid-segment. It connects the midpoint of line segment AE with the midpoint of line segment EN, so it's a mid-segment of the triangle as well, which means it's half of the remaining side, which means it is 2 times 29. It is 2 times 29, which 2 times 29 is 58. 58 there for the correct answer. Okay, for line segment AN, that big side, 2 times 29 equals 58. Okay, now one thing I want to point out to you, and you may have not thought of it before, okay? So when we said that it's 2 times 13 for side AE, that means each of the 2 sides that it's split in are also 13. So the mid segment is actually the length of half of the third side, okay? If CP is 29, then each of these little pieces down here is also 29. That's why the whole thing ends up being 2 times 29, or 58. Okay, let's see if anybody's figured out CT yet. Okay, so CT is this side here, okay? And so, good. Quentin, can you tell us how you figured out CT? You're correct. Can you tell us how you figured it out? Just when I called on him, I got that he left the meeting and joined the meeting. So Quentin, are you there, sir?
Yeah, I just need to join
Okay,
up
great.
through that.
Okay,
All right.
thanks.
So I did 43 divided by 2.
Okay, how did you know that?
Because, what's it called? 43 was parallel to the, what's it called?
CT to line CT?
Yeah.
Okay,
CT. So
right. Perfect. Okay. So he said this time it was the bigger side that we knew. So he just divided it in half. And 43 divided by 2, he's exactly right, is 21.5. We will have some decimals this unit, so don't be, freaked out when you see decimals. Okay, that was correct. It's 21.5. Now it asked for the perimeter of the whole thing. So Quentin, how did you get your perimeter? What did you do for that?
So I did 43 plus 26 plus 58.
Right, just adding the 3 sides, making sure that you're doing the perimeter of triangle AEN. There's at least one of the problems where it asks for the perimeter of the small triangle inside, and I automatically did the big triangle, not paying attention. And that's why I said the letters really matter. Make sure you're finding it for the one that they're asking for. So AEN is the big triangle on the outside, so we want those sides. And that's right, we said 2 times 3 was the 26. The 43 that we were given and the 58 that we found. And so what did you get for your total perimeter then, Quentin?
127.
Beautiful. And so we can put that in the blank. Follow-up questions for me. You guys are doing well on these. I see people figuring out the missing parts. This is super important. That's really good. Like I said, one of the connections I wanted to make here is that if you look, and we only see it in this picture because they did the midpoint of all the sides. When we say that big side is 2 times the mid segment, that means each of those 2 little pieces is the same as the mid segment. Okay, so 21.5 plus 21.5 does make the 43. Okay, all right, let's try another problem. You guys are doing great. Okay, so this now, oh, and I kind of spoiled the fun on this one. Okay, this is the same picture that we were just looking at, and they ask us to find all those little pieces. And Ms. Weaver kind of already spoiled the fun there. Go ahead and see if you can quickly fill that in. It's asking for the little pieces, so it's asking for what these 2 pieces are, EP and PN. And I kind of spoiled that fun because we just talked about that, how if the mid segment is 21.5, then each of those 2 little pieces is also 21.5. So this was helping make that connection. Sorry, I spoiled your fun. I did want you guys to see that, but see if you can go ahead and fill it in if you didn't do it while I was doing the notes. Okay. Or maybe it's especially good practice to go and make that connection right after we just talked about it, doing it on your own. Yes, yes, yes. And again, I love seeing some of you guys working in the beautiful color coding. For me, being a visual learner, it really helps reinforce what's going on there. Okay, excellent. Any questions for me on that? I don't want to waste any more time on that since we already kind of talked about it. Okay. And Ashton, I'll let you help me with another problem since I kind of had to answer your question for this. Okay, so let's look. Now we're moving into the next section of our lesson where we're talking about parallels. If a line is parallel to one side of a triangle and intersects the other 2 sides, then it divides those sides proportionally. Okay, so we've been talking about how a mid-segment is in fact parallel to the remaining side, but we didn't talk about how the mid-segment split it. We already knew how the mid-segment split it because it was a mid-segment. It split it in 2 equal parts. But if we have parallel lines, even if they're not a mid-segment, okay, they're parallel to one side of the triangle, and you can see it here. Those 2 sides are parallel. Then it splits the sides proportionally. And when I do this, these kind of problems, I kind of like to just draw the line itself that's parallel to the 3rd side. I like to draw it out longer than that. And these are my fractions that it makes. Let me change that color coding. Okay, A is to A plus 4 as 12 is to 18. So do you see how if you just kind of extend that line, it'll automatically set your proportion up for you? I love that. That's like one of my favorite things to do. I think it makes it very easy to set it up correctly. And you can see that A is to A plus 4, A is to A plus 4 as And I keep switching colors here. Okay, 12 is to 18, and the other side is 12 is to 18. Okay, and then it's just a proportion, so then we'll just cross multiply and solve for it, and that's what we're going to be doing. Let's see what with our parallels here. So let's go ahead and try a problem like that. Okay, so if these, and then we start with one where it's kind of rotated and kind of weird to see, but it'll still work that same way. If you use Miss Weaver's trick, we can totally do that. What it's saying is if these two sides of the triangle, if this side of the triangle is parallel to this line, then if I just like extend that line further, it'll set up my fractions for me. 32 is to x as 24 is to 9. Now, if you put x is to 32 as 9 is to 24, you'll still get the same correct answers. Either setup is okay, but we want this to be our fraction, this side to be our fraction, 32 over x or x over 32 either way, and 24 over 9 or 9 over 24. The important thing is that you make sure that x and 9 are both in the same position in your fraction, and that the 32 and 24 are both in the same position in your fraction, either both top or both bottom, okay, when you're setting it up. Usually it's not as hard as this picture. It's kind of weird the way this picture rotated it. Usually it's more like that picture on the previous slide where we can just see that proportion set up, okay? But that's just one way to think of it or work a problem. That's how Miss Weaver, way back when I was in geometry, that's how I remember seeing these, and it was really helpful to me. Again, I've said I'm a visual learner. Okay, once we have our proportion set up, this one has the x by itself, so if we want, we can just cross multiply and divide. So it would be 32 times 9. This is what you'd be putting in your calculator, divided by 24. Or if you're just a big fan of cross multiplication, you can just cross multiply, okay? Meaning you can do just 32 times 9 equals 24 times x. And then in your next step, you can divide both sides by 24 to get rid of the 24. Either way, we'll have that x is 32 times 9 divided by 24. You see we get the same fraction either way here. Okay, more than one way to work a problem. Let's go ahead and have you guys try finishing that and see what you get for x. If you want to work on simplifying by hand and trying to work without your calculator, this is a great time to work on your number sense and do that. You can simplify that fraction before you multiply it to keep those numbers smaller. Okay, very good. Jalay, correct answer there. What did you get, Jalay?
12.
Yes, very nice. You should have gotten x equals 12 final answer. Question for me on setting up those proportions. Questions about that? Okay, let's try another one with a different picture, see if we can still apply that. Okay, oh, or is that all we get for the one? Okay, I guess they thought it was an easy idea. They just gave us one to practice, okay? It says you can also find out if the lines are parallel. You can set up the proportion and check to see if their ratios are equal. Now, this is similar to when we were checking to see if triangles were similar. We set up the proportion, but then check to make sure that each side of the proportion is in fact equal to the same number. Okay, so let's take a look at that. So here's one. And again, if you use Miss Weaver's technique, I like to just extend that line. It'll help me set up my proportion correctly here. Okay, so that means 15 is to 20 as 18 is to 24. And again, this is the way I usually like to see it. You can always rotate your picture to just turn your paper to help you see it that way. I wanted to say for some of you that are working and you have a really fat pen where it's hard to write on the screen, on your Pear Deck slide over to the left, close to your little pear symbol, there's a little slider that you can slide up and down to make your pen skinnier or fatter. And so you can make your pen skinnier and it will make it much easier for you to write. I see some of you really struggling to fit your work on the page. And so that'll really help. You can also change the color of your pen there over close to there. So it's kind of fun to figure out those pen controls in Pear Deck. if you haven't seen those before. Okay, now be careful here. Notice that there's no x here. We're not solving for x. We're checking to see whether or not these are proportional. Because if this line splits these sides proportionally, then we'll know that that line is parallel to the third side. Okay, that's what we're checking for. Is that line BC, in fact, parallel to line segment DE, the third side? Well, let's check. Let's break out our calculators. And I'm going to just open my Desmos calculator. So I keep my Desmos calculator bookmarked here so that I can always find it. That's a good suggestion for you. You see, I've got my calculator right up here. Okay, so let's check and see. Does 15 over 20 equal 18 over 24? So if you click on your keyboard there, does 15 divided by 20? And of course, you can simplify those fractions by hand and see if they do, right? So if I simplify that fraction, well, if I just put it in my calculator, because I think that's what most of you will do, I get 0.75. If I simplify that fraction, 5 goes into 15 3 times, 5 goes into 24 times. So it's the fraction 3/4, which is 0.75. Okay, does the other side equal that? Well, if I put it in my calculator first and see what that equals. Okay, so on my calculator here, I'll just click a new line because that way I can keep both numbers there to compare. Does 18 divided by 24? It does equal 0.75. So if you get that they simplify down to the same number, then that means, yes, they are equal to each other. They are proportional. Oh, and then what did I do? When I was going to write, I clicked another number. So let me go back and correct my work here. So that's what I like about this, being able to see your work. Okay, you can compare your fractions. You can see if they match. And then if you mess something up or if they're not the same, you can double check your work to make sure that you entered it correctly. If I just simplify the fractions myself, 6 goes into 18 3 times. 6 goes into 24 4 times. And so if I was doing it by hand, I would have seen that it simplified to the same number every time. The reason I wanted to show working it on the calculator, a lot of these that we're going to get are not going to simplify down to pretty fractions like this one did. So a lot of them you're going to want to use the calculator anyway. So I just wanted to show you that. All right, let's hop back to our slide then and see what that means. Okay, so the two did simplify to the same number every time. They were equal to each other. The sides were split proportionally. So what does that mean? That means that line segment BC is parallel to line segment DE. Okay, remember our geometry notation? We write the two letters, and here they should have had the bar over them here. Without the bar, it means the measure of them. That means line segment BE is parallel to line segment DE. Now, I wanted to tell you guys, I just learned how to share the Pear Deck teacher dashboard with Mr. Chen. So you see Mr. Chen is here with us today. So because he'll be able to look at the teacher dashboard while I'm teaching, you may start to see comments showing up on your work. So just be aware there's a little alert for you in Pear Deck that says you have a message. And if you click on that, you can see Mr. Chen's feedback for you about your work in your slide. So not everybody will get those, but when you see those little alerts pop up, that's how you can go check them, okay? And so I just wanted you guys to know to be looking for that as we're all learning all these new features in Pear Deck. Okay, and any question on that notation? So this is your final answer to the question. They asked if they're parallel. The answer is yes. Line segment BC is parallel to line segment DE. A parallel symbol there is looking a little messy. It's just two straight bars, like two lines that are parallel to each other. I think of it as lowercase l's next to each other is what it kind of looks like. Any questions for me on that? What questions can I answer? All right, and I'm seeing beautiful work and people have found their skinnier pins. It makes the world better. Okay. All right. Now, I do want to see more of your responses in Pear Deck. If you've got kicked out of the Pear Deck or maybe never joined, the code's up here in the corner. Let's get you on our Pear Deck XTV ISW for the next couple problems. Code's right up here in the corner. You can always join late or rejoin if you missed joining originally. Okay, so they want us to solve for X. This is when I say, what do you spy with your algebra eyes? Okay, there's a lot, or your geometry eyes here. We're going to need both our geometry eyes and then some algebra eyes to get the equations right, okay? There's a lot going on in this picture, and we know a lot of things at this point in the year. So what's helpful to us, we want to get any true equation with x in its setup. We want to get any true equation with x in its setup. Okay, so the first thing as I see is I see that those parallel lines, and I'm like, cool, I'll just extend my bar and get my proportion. So if I extend that bar to get that proportion, the problem is, notice that 82 is not this little piece right here. 82 is not that little piece. It's not. 82 is the whole side. So I can't put 82 in my proportion. If I'm setting up my proportion, it should be 2x plus 8, this side, over 5x minus 4, equals 28 over whatever that little piece is, that pink piece is there. Be careful that you do not plug that 82 in. That 82 is not that little piece. So how can I find that little piece? Thoughts or ideas? What do you see? What are you thinking?
I think I know how we can get it.
Okay, Ashton, how would you do it?
Basically, all you need to do is you need to take the whole side and subtract it by the side that you already have, and
Very nice.
be the segment.
Okay, exactly. So we already know this little piece is 28. So if we do take that whole side 82, and subtract the 28 that's already part of it, what did you get, Ashton, for that remaining little piece?
54.
So we borrow from the 7. I'm doing it by hand, so I'm just checking real quickly. Yes, beautiful. Okay, so that's 54. So now we have our proportion there, 28 over 54 on that side. That's beautiful. Exactly right. Okay. Some of you, I think, just doing it kind of quickly in your head, I see some incorrect numbers there. So make sure that you got, when you did the 82 minus 28, I'm just going to check myself. Yeah, it is 54. And so make sure that you got 54 for that. Also, make sure you put 54 in your proportion in the same place that 2x plus 8 is. So I see a couple people, this is why I like showing your proportion just like this. 28 should be on top and 2x plus 8 should be on top. So make sure you've got 28 and 2x plus 8, either both in the top or both in the bottom, okay? Because that's why I like dividing it like that. Good, because then we'll get it set up correctly. All right, so now our proportion is set up. What are we gonna do with it? We're going to cross multiply this time. We can't just cross multiply and divide even though it's faster because we have the x in 2 positions. So we're just gonna cross multiply it. So let's try that. We're gonna get 54. Now make sure you put that 2x plus 8 in parentheses because you're gonna have to distribute that 54 to both parts of it. Same thing, that 28 goes out front, and 5x minus 4 needs to be in parentheses because we're going to have to distribute it to both pieces of that. All right, so let's see what you did. Jason, did you try adjusting your pen size, sir? It'll just give you more space to work. No biggie if you, it's just over on the left side of your screen. There's a little slider. It kind of looks like a triangle. When you click on it, it kind of makes a triangle and slides up and down, and that'll make your pen fatter or skinnier. Okay. So when we distribute, 54 times 2x is 108x. 54 times 8. Ooh, we're getting some bigger numbers today. I hope you're ready for it. Is 432. On the other side, 28 times 5x. And you're fine to use your calculator. Is 140x. And remember, when we get to the point that it's just algebra, everybody should be trying this algebra on their own. All of us need algebraic practice, okay? Make sure that you're getting it right. Avi, I'm happy to see you in class. You weren't here when I took attendance, so I'm just glad you're here, ma'am. I'm sorry if you're not feeling well, but that's great for you to go ahead and try to follow along and join us. And I agree, passively watching you can absorb a little bit by osmosis that way. And so that's totally better than just being absent. So I'm glad you joined us even though you're not feeling well. Okay, let's see. Sorry, I'm trying to get my attendance to fix it because I just spotted Avi in class. So that's why I abandoned our problem halfway through it. Let me go ahead and get that. It's 28 times -4. I got -112 there. Keep going while I get attendance updated and see if you can finish that on your own. We're just combining like terms, gathering our x's to one side, putting our numbers on the other. Okay. How did you do in my absence? Did you get it finished? Let's see. We have more x's on the right, so I'm going to subtract 108 x's from both sides. That's going to give me 32 x's on the right. So I want my numbers on the other side, so I'm going to add 112 to both sides. It's going to give me 544 on the left. When I divide both sides by 32 to get the x by itself, it's going to give me final answer, x equals 17. Wow, so it turned out to be a nice number. It didn't turn out to be an ugly decimal. Okay, let me give you a second to finish trying that by yourself. Good, some of you did already have it. Some of you are kind of paused in your algebra. Do I have questions about the algebra? Does anybody need help with any of that algebra? Good. I'm seeing correct work. What questions can we answer? Carmen, good question. Let me double check and see. You do always want to get my attention like that if you come to class late. Carmen, I did not have you, so thanks for mentioning that. Anytime you come to class late, guys, make sure and get my attention, whether it's unmuting or typing it in chat, so that if I've already taken attendance, I can update it with you being tardy instead of absent. Okay, so Trevor, doing it on your paper is good, but if you'll share in the Pear Deck sum, then I can kind of check it and Mr. Chen can follow your work and give you feedback as well. So doing it on your paper is good as far as you can go back and look at it there. But remember, I do email these Pear Decks back out to you. If you haven't seen the Pear Decks coming to you, maybe check your junk folder. Every day when we finish our Pear Decks, I email them out and they come to your school email and it'll have both your work and the other work. If that's just not going to work for you, and if you just are super like paper, I understand that. Okay. All right. Most of you that are on the Pear Deck that I can see your work are finished with that problem, so we're going to go ahead and move on. I'm checking our time to see how we're doing. Okay. All right, so let's do one more of these together. Okay, and then I'll turn you guys loose for your asynchronous time, or those of you that want extra practice can hang around and we can do another one. Okay, so this is one of those where the picture is turned kind of sideways. It's the same idea as the problem we just worked, so see how you did. You can either visually picture rotating it. For me, I'm just thinking, okay, I like to just extend that line. Now, what's different about this picture is that here we don't have a closed triangle. We can imagine it making a closed triangle. Like if we wanted to imagine these extending and touching to make a triangle, we could. If we imagined it splitting off to focus on just that, we can imagine that. But that's not what the picture shows us. Okay, that's not what the picture shows us. But it is true that how when we were inside a triangle, okay, when we were inside a triangle and parallel lines split the sides proportionally, Miss Weaver extended her side and it split the sides proportionally. Well, it turns out that if, say it's not a triangle, say you just have 3 lines that are parallel, And now I'll erase the top of my triangle. So you have 3 lines that are parallel that intersect 2 other lines, okay? They still split those sides proportionally. They do still split the sides proportionally. So you can set up a proportion with this side equal to a proportion with this side. It will still split the sides proportionally, just like it did when it was a closed triangle. So it's the exact same idea. We're just doing it now with a set of parallel lines. They don't necessarily have to close at the top to make that triangle. So let's see if we can look at this picture in the same way that we've just been looking at those triangles. So for Ms. Weaver, I'm going to find that middle parallel line and I'm just going to extend it. And this works for me to help see my 2 fractions. That means this side will be proportional to this side. Now, we have that word of caution again. Notice that we don't have that little piece there, but we do have enough information to find it, okay? How are we going to find it? You can unmute and tell me if you remember. How are we going to find that little piece that we need to set up our proportion? We did it on the last one. Can you tell me? That's right, Jalay. We're going to subtract it. Exactly right. So we know that whole side is 49. So we're going to subtract the little 28 that makes up one of the pieces. That's going to give me 121. Will be my remaining little piece there. Okay. And you can double check yourself. 28 plus 21 does make 49. Okay. So you can check your subtraction there. So let's set up our proportion. Let's set up our proportion. I'm going to work over here on the side of my screen because I have a little more space here today. So that middle line split it. And so I just want to put, now I'm going to put the 36.4 over X. Because I put the 36.4 on top, I'm thinking if this is my numerator on this side, just make sure that you put that 28 that's on the same side of the line on top as well on its side. So I'm going to put 28 over 21. If you did X over 36.4 equals 21 over 8. Okay, sorry, 21 over 28. Sorry, Ms. Weaver. Okay, that's still correct, okay? I just thought of the left side as my numerator this time, so I put those on top. But if you saw the right side as your numerator and put those on top, that's okay too. As long as you have the ones that are on the same side of the line that we extended, both in the numerator or both in the denominator, we'll get the same correct answer. Okay, so let's solve that one. This one only has X in one position, so I can cross multiply in the direction that does not have the variable and divide by the other number. Notice Ms. Weaver said that long sentence. I say that sentence in my head every time that I decide which ones I'm going to multiply. I say cross multiply in the direction that does not have the variable and divide by the other number. So the 36.4 times 21 did not have the variable, so I'm going to multiply that and divide by the 28. And so in your calculator, you would just put 36.4 times 21 divided by 28. Or if you're just a big fan of just regular cross multiplying, then you can just do 36.4 times 21 equals, and you can cross multiply in the other direction, 28 times X or 28X. Okay, and then you'll still just get those numbers and divide both sides by X. Okay, I did it all in one step over here on the left. So I got 27.3. If you do it this other way, let's go ahead and try that the other way. And again, you're okay to use your calculators. 36.4 times 21 gave me 764.4 equals 28X. Then for my last step, I'll just divide both sides by 28. And I get 27.3. So correct work will lead to the same correct answer, okay? Okay, and I'm seeing lots of good setups. Yes, good, good, good. I'm seeing correct answers. Very nice. And I saw the smiley face. I love it, Jalay. I also like to give myself smiley faces when we get it right, when we do good work, especially when we're doing hard things. So I like that positive encouragement for yourself. Questions from anybody on this one? Okay. If you feel like you're doing fine, okay, we're into our asynchronous time a little bit. Do I need to leave this up for a second? Are we doing okay? Okay. If you feel like you're doing okay, next thing on our agenda is the quizzes. The link is right here in the Schoology page. Okay, I can copy that and put it in the chat as well. Okay, you can go to quizzes, and the quizzes has both content from today's lesson and content from last lesson. Okay. When we were talking about ways to prove triangles similar, because both ways to prove triangles similar and midsegments and parallels are going to be on our assessment next class. Okay, so you can go ahead and work on that. It's already assigned in when you log into quizzes, it's already assigned to you. It's the 6.3 and 6.4 review. If you'd like to do one more of these, I have one more of these problems in our pair deck. So for those of you that would like to, let's go ahead and work one more of these together. It's the last one I pulled, okay? Again, when you see these pictures with just the parallel lines, remind yourself, it's the same idea as if it did make a triangle. It's the same idea if it did make a triangle and split it, okay? It just doesn't make a triangle, but it's okay. We still know that that middle parallel line, if we extend it, it splits the sides proportionally, meaning this side will be proportional to this side. Oops, let me change colors there. I like changing colors because it just helps me keep things together and correct, okay? So if we set up our proportion, those two sides should be split proportionally, meaning 2x plus 5 should be to 22 as x plus 10 is to 16. And you know, we haven't practiced reading proportions out loud, but that's the way you read that proportion. You read it as 2x plus 5 is to 22 as x plus 10 is to 16. Okay, so they're proportional. The relationship will be the same relationship. You do the quizzes now, Benjamin, if you're feeling ready to. If you feel like you want a little more practice, then you're doing one extra problem with me, okay? Remember, I need to see that you're in the quizzes and working on it before you leave, go asynchronous. But once you're on and I can tell you're working on it, you can do the quizzes asynchronously. Okay, so let's go ahead and finish this. I know, we have lots of things to circle and mark here. Okay, so let's do this. Now we have the x in two places, so we can't just cross multiply and divide. We're going to have to just regular cross multiply. So I'm going to start here with 22 times x plus 10 equals 16 times 2x plus 5. Okay, and from here on out, it's algebra, but we all need practice with our algebra, so let's give it a try. Okay, so I'm going to distribute. 22 times x is 22x. 22 times 10 is 220. When you multiply by 10, you just add a 0 at the end. 16 times 2x will be 32x. 16 times 5, that should be 80. Okay, I've got more x's on the right side this time, so I'm going to subtract 22x from both sides. It's a minus. That'll cancel. That's going to give me 10x. Then I want the numbers on the other side, so I'm going to subtract 80 from both sides. It's going to give me 140. Divide both sides by 10. And I get x equals, the zeros just cancel, 14. Ding, ding, ding. Is that what you got? I'll give you a second to finish up. Very nice. Saeed had it. Excellente, sir. Okay, and that was all the practice problems I had for it today. Okay. So Benjamin, I believe that you can do multiple attempts on the quizzes. So if you want to write down what you thought the correct answer was, I believe once you get through the whole quizzes, you can go retake it again to try it again. So write down your answers so you won't have to repeat all the work again. And then you can go back and try it again. Okay. All right, questions for me on this last one or questions in general before we get working on the quizzes? Okay, then I'm going to go ahead and pull up my quizzes dashboard. I'm going to end the Pear Deck so that I can send these out to you. And again, you'll be getting an email with the slides in it. Look for it and check your junk mail if you don't see it. I always put the date, and so today is January 13th. I put 5th block geometry, and then I put the topic that we were doing. And today, this was called mid-segments and parallels. So you can kind of find it again. Okay, and let me see how many of you are in the quizzes, how we're doing there. So I watched a documentary on HBO about a group called the Bee Gees from the 70s and 80s when I was growing up. And so now if you hear Miss Weaver humming, it's just because I've got their music in my head. I catch myself humming and it makes me laugh. Okay. Right. And then I can see, Benjamin, I can see how many attempts you've made. Like it'll show me if you got that grade in 1 attempt or 2 attempts, and I can go back and look at your different score results. And so that's good news for people. Like if you're trying it and getting a bunch wrong, then know that you can, that you can go back in and try again and you can learn again. Tristan's here too. Thank you. Tristan, I saw you in the quizzes. Make sure and tell me if you come into class. I had you marked absent for class today, but I'll go back and switch it. I'm glad you're here today and working with us. So always just kind of type it in chat or unmute and tell me when you come into class so that I can give you credit for being here. Good to see you, sir. Now, as you're working the quizzes problems, this is class time. I am here to help. I would love for you to share your screen and we could work on a problem together. I could help you with a problem that you're having trouble with, okay? I also have all the quizzes problems pulled up, like I already have them on a document. Let me show you guys. They're in our Schoology folder too, I believe. So if we go here, if you toggle on today's, that's the blank practice and the key to the practice. That's our Pear Deck problem, sorry. But I should have in the folder, no, I'll add it real quickly. I'll add the blank quizzes paper, the problem. So if you just like working your quizzes on paper, you can print this out, or I can just pull it up and we can work on problems together. Okay, so let me show you where that's at. So in today's folder, the blank quizzes problems are there, and I can pull them up and we can go over a problem together if you have a problem that you'd like to go over, okay? So just let me know if you need help with anything. I'm happy to help, and I do have the problems so that you can just kind of tell me which problem and I can pull it up and we can go through it together, okay?